Hey, it's Miss Miklos, and in this lecture we are talking about solving systems of equations using the method of elimination. And back in Algebra 2 we called this linear combination. So we've done this before, so pretty much everything we're going to do today is review. So just to review, in the elimination method we want to eliminate one variable from both equations, either the x or the y, it doesn't matter, so that we can solve for the remaining variable. Then we can back substitute into one of the original equations to find the solution for the other variable. So whenever we start, we need to obtain coefficients for x or y that differ only in sign by multiplying all the terms of one or both equations by chosen constants. Then we're going to add them together and eliminate for the desired variable. And I actually think that sounds more complicated than it really is. So here we go, number 1. First thing we need to determine is should we cancel out the x's or the y's. And in this case, I'm going to choose the y's because I see that their coefficients are already opposites. So I'm going to go ahead and add these together. So x plus x is 2x. Y plus negative y cancels out, and 4 plus 2 is 6. So when I divide by both sides by 2, I get x equals 3. Then I can substitute into either equation. I'm just going to choose the first one in order to solve for our y value because we know that we should get an ordered pair as our solution. So in this case, I would get y equals 1. So my ordered pair would be 3, 1. In order to double check that it works, I can plug this into both equations. So 3 plus 1 is 4, 3 minus 1 is 2, and we're good. Okay, so let's do another one. This one is a little bit more difficult because we don't have things that are opposites already. And so we really have a choice here. It doesn't matter, we can either cancel out the x's or the y's. I'm going to choose to cancel out the y's here just because I already have opposite values in the sense that I have a positive and a negative. I know the smallest number that 3 and 4 both go into is 12. So I'm going to multiply this top equation by 4 and this bottom equation by 3. So I would get 20x plus 12y equals 36, and 6x minus 12y equals 42. So now I'm going to add these together, and I would get 26x, my y's cancel out, equals 78. When I divide both sides by 26, 78 divided by 26 is actually 3. So now that I have my x value, I can substitute into either one of these to solve for y. I'm just going to use the first equation. But I want to stress to you guys that when we're using elimination, there are definitely more than one, there's more than one correct way to go about doing it. So in this case, I get 15 plus 3y equals 9. When I subtract 15 from both sides, I get 3y equals negative 6. So y is negative 2. So my solution here is 3, negative 2. Let's check real quick. 15 minus 6 is 9. 6 plus 8 is 14. So it does work in both equations. Okay, number 3. Looking at number 3, I would definitely cancel out the y's because I already have opposites. The least amount of work I can do, the better. So I'm always going to choose whatever's easiest. If you wanted to, you could cancel out the x's. We would get the same exact solution if you did everything correct. So when I add these together, I get 8x equals 12. So I get x is equal to 3 halves. And I know that when we get fractions, it kind of freaks us out. So let's go ahead and substitute 3 halves in here. So I would get 9 halves plus 2y equals, I'm going to write 4 is 8 over 2, so I have a common denominator. When I subtract 9 halves, 8 halves minus 9 halves is negative 1 half. I know that to get rid of that y, I need to divide by 2, and dividing by 2 is the same thing as multiplying by 1 half. So I get y equals negative 1/4. So I get 3 halves, negative 1/4 as my solution. This is definitely the type of answer that I would plug back into both equations to make sure that it makes a true statement. And it does. Number 4. Hopefully you guys are seeing that this is somewhat repetitive. As soon as I know how to use this method, it's pretty straightforward. It's actually my favorite method for solving a 2x2 with linear equations. Notice that we're not dealing with anything that is quadratic or higher order. In that case, we would need to use substitution. So looking at 4, I'm going to cancel out the x's first. So I'm going to multiply this top equation by 2, because that would make my x's opposites from one another. So I get 2x minus 4y equals 6. My other equation is staying exactly the same. Negative 2x plus 4y is equal to 1. So when I add these together, something strange happens. My x's cancel out and my y's cancel out, so I just am left with 0 on the left side. On the right side, 6 plus 1 is 7. And we talked about this earlier this chapter, where when our variables cancel out, we need to ask ourselves, is this a true statement? Is 0 equal to 7? And the answer there is no. So what this is actually depicting is 2 parallel lines that never intersect. So our answer is going to be no solution. And our last problem for the day, example number 5. I'm going to cancel out the x's again, so I need to multiply by negative 2 this time. So I get negative 4x plus 2y equals negative 2. My other equation is going to stay exactly the same. And this time when I add them together, everything cancels out. So I get 0 equals 0. So now I need to ask myself, is this true? Is 0 equal to 0? And obviously the answer is yes. And what that means is that these two equations are actually the same line. And we learned when we have the same line, we write our solution as all the ordered pairs on the line, 2x minus y equals 1. If you guys wrote this second equation, that's fine. If you wrote this equation, that's fine. They're all saying the same thing. So it's pretty straightforward. That's how we use elimination to solve 2x2 systems.